Okay, excuse me. All right, here's another one. Um, where's my thing at? Where's my app at? Show me. There it is. Okay, boom. There, next page. So let's do the mother of them all. The very last problem. 6. I'm on 3D.2, number 6B. So here we are. We have 3 to the n power times n minus 1. Now, this took me 2 tries. I did it, on paper first. The first time I thought, oh, maybe there's some cute way to pull the 3 to the n out of both sides. Kind of like that big factoring problem, which is kind of how we did 2A or 6A. But that just didn't go anywhere. So, that's something to keep in mind. With these problems, it may take a couple different approaches. And you kind of gotta start to see, is this going to lead somewhere? So I thought, okay, that was a mess. Well, what's the other thing? Well, I'm trying to simplify it. So maybe I should actually multiply, start to distribute that 3n in and see what happens. And that is promising. So let's do it. And I'm going to do it in red. So I'm going to distribute it in, and very carefully keeping track of the negative signs and all that. So I'm going to have 3 to the n times n, right? That's that first one. And then I'm going to have minus 3 to the n, because 3 to the n times negative 1, minus. And that's going to be over 6. And then the other side, I'm going to have, let's bring that in, that minus 3 to the n times n. So negative 3 to the n times n, that negative's in front of it. And then I'm kind of seeing this whole thing and distributing it in. So I'm going to multiply that again, negative 3 to the n times 1. So it's negative 3 to the n. And that's over 6. So now if I look at it and I combine these two together, you really want to think there's kind of like a plus here. I'm adding those two together. You could have also, if that freaks you out, you could have kept that negative sign here and then and then did the 3 to the n separately, like a positive 3 to the n, and then distributed the negative in. I just distributed it all at once. So hopefully that makes sense. Well, you have a fraction with a common denominator, so we can combine them. We can have everything over 6. So I'm going to switch that to blue, and look what happens when we do that. You have 3 to the n times n, which is messy, but then you have over on this side, you have negative 3 to the n times n. They cancel out. Not bad. Now here you have negative 3 to the n and negative 3 to the n. So you have 2 of them. You have 2 times negative 3 to the n, all over 6. Now, see how I'm writing this? Just writing it that way helps. Because I could have also written it like this. 3 to the n plus 3 to the, or 3 to the n minus 3 to the n, right? I'd have 2 of them. That's just weird. So it was good that I could see that I had 2, like the way I said it. It's like 2 times 3 to the negative n. Now I can simplify the 2 and the 6. So that's going to become, I'm going to write it over here, 1/3. So I have 1/3, and then if on top, don't forget I still have negative 3 to the n. So now what you have to be able to see is, let's get that negative 3 out. Let's take this negative sign. So I'm going to rewrite that. I'm going to write it on this side. I'm going to write it as negative 3 to the n over 3. So when you think of it this way, you have the same base and you have exponents. You don't always think of it, but there's a 1 there. So what's the rule when you divide? You subtract powers. You subtract exponents. So that's going to be 3 to the n minus 1, because this n minus 1, and there's a negative out there, and that, believe it or not, is your final answer. I should double check that, make sure that is indeed. I will double check it. The very last problem, it is negative 3. There we go. So hopefully that makes sense. You followed along. And let me know if you need any more help. Oh, my Amazon package just came. Yay.